So here are those homework questions, and don't forget, when we do a sample mean or sample average, that's x bar. This is the way we figure out the standard deviation for our sampling distribution. Now, we still have to pay attention to that 10% rule. And also, down here, the central limit theorem. Now, the central limit theorem says, and like I mentioned in class, it's pretty remarkable that now if they give you a question where the distribution is a nice normal curve, then everything is cool and we can just keep going as usual if they tell you that in the problem. But a lot of times, in fact most of the time, you're going to have skewed data or something crazy that looks like this. So that's kind of weird if we had a distribution like that. Instead of everybody being kind of in the average, and some are high and some are low, but those are smaller groups of people or things or whatever we're looking at. But this one is just like we have lots of random stuff going on as far as what our values are. But it is kind of interesting that we only need 30 in our sample size if we sample over and over and over again, and everything works out pretty awesome. So that's kind of interesting that happens, at least to me, because I've looked at this quite a bit. Now, let's take a look at this question. So on this first one, find, let's see, fifth graders, and it usually takes them an average of about 2 minutes to do these problems, right? With a standard deviation of 0.8 minutes. Find the probability the randomly chosen fifth grader will take more than 2.5 minutes to complete the problem. Show your work. Okay. So this is just one fifth grader, not a bunch of fifth graders and taking the average. So this is kind of our regular old z-score. So z-score, like we've done before. I'll do this quickly. I'll try to. Let's see. What do we got? We got 2.5 minutes for that one kid, a little bit above average because it's usually 2 minutes, with a standard deviation of 0.8 minutes. Okay, let me do the math on this one. So we get 0.625, which that means is, just as a reminder, here we are, should be here, and we're 0.625 standard deviations above the average. Now, what would it mean to be 6.25 or more above the average? Okay, so let's do that with normal CDF. So with normal CDF, I get 0.73. That's indicating that that's all of this stuff below. Where is it? Below this, that's 73%. So above it, subtracted from 1, and you get 26.5. So 26.5. So what does that mean in this situation? I have a 26.5% chance of randomly picking a kid that is going to take 2.5 minutes or more to do these math problems. Roughly 1 out of 4 kids is going to take longer than 2.5 minutes. Okay, let's look at the next one. Same situation, except instead of taking a single kid, this is the second problem here, we are going to look at 20 kids. Okay, and take the average. So what we're going to do is we're going to get that new standard deviation, and the new standard deviation is going to be the old standard deviation divided by the square root of your sample size. So it's going to be more accurate information because we have more students involved in the sampling process instead of just a single kid, which means we're going to be more accurate and a smaller standard deviation. So in this case, they want you to make a graph of the normal distribution, and let's take a look at what that might look like. So here's our normal graph here, and right in the middle we are going to have, what was it? The average was 2 minutes. And remember, we have 3 standard deviations until we have almost everything like that. So I'm going to add 0.178 to 2, and then do it again and again and again. So I'll fill that in. So if we look at this, I just added 1.78, 1.78, 1.78, 1.78. Now they say, well, what's the real deal is here, what is the probability that we get a group of 20 students, and from these 20 students, their average is 2.5 or above for the whole group of 20, 2.5 and above? Well, the chance of that happening is extremely small, because 2.5 is right up here, and there's only like a teeny bit of the graph left versus 26% for just a single kid. So, like I said, when we take a group of students and take the average, it's much more accurate information. Okay, let's do the next one. Okay, here we go. Now we have 250 men, simple random sample of 250 men. What is it? Cholesterol level of 188, standard deviation of 41. Sketch the sampling distribution and calculate the probability that the sample of mean will be greater than 193. So first, let's get the new standard deviation. So the new standard deviation, let's just call it like that. Whoops. Like that. And it's going to be the old standard deviation divided by the square root of the sample size. That's how we do it for a sample mean. Sample proportion is a little bit different. Okay, here we go. Okay, this is just a rough sketch of what it should look like. We start with the mean, which is right in the middle, 188, and we add 2.59, 2.59, 2.59. That gives us almost everybody in this situation. And remember, we're taking an average of a sample of 250 guys, or this subtract 2.59, 2.59. I didn't put all the decimals because it just didn't have enough room. But that's kind of what the graph is going to look like. And we're looking at, what, 193? So it's a mean, an average of 193 for a group of 250 men. What's the probability that we would get that in this situation? Well, we're up here. So we'll do the z-score. Looks like it's almost 2 or more standard deviations above the average. Okay, let's do it. Okay, z-score 1.93. Just a coincidence that our question is talking about 193. But anyway, we're going to do normal CDF and subtract it from 1 because we want to know what's the probability that it's greater than that. Remember, normal CDF tells us the area underneath that. Okay, so let's do it. Normal CDF of this number and then subtract from 1. Let's see what we get. So here's our answer. And what that tells us is that we have about a 2.6% chance in this situation of getting 250 guys together, taking their blood cholesterol, and the average of that whole group is going to be 193 or higher. Very low chance of that happening. There it is.